Welcome back, Geometry. Today is Unit 7, Day 9, which is Angle of Elevation and Depression. Okay, now this is where we apply trigonometry to real-world applications. Trig is used to basically measure things we cannot measure with a ruler, such as the height of a mountain, how high an airplane is, how far away something is. And with this, it's used a lot. So, two things we talk about in geometry with trigonometry is this concept of angle of elevation and depression. Now, when someone stands and looks out straight, right, you have your horizontal line of sight here. But then as you start looking up, what happens is you create an angle with your horizontal line of sight and the object you're looking up at. That there is called the angle of elevation. Now, what happens if we're up top? So say you're in this balloon, right? And you want to look down at the person. Well, your line of sight is here, but then as you look down, your horizontal line of sight and the angle of depression, right, end up creating this angle here, which is the angle of depression. Now, the common mistake is students want to, make this right triangle and use this angle as the angle of depression, but it's not. All right, what you have to understand is up top, you have a horizontal line of sight, and down below, you have a horizontal line of sight. What happens is these two lines of sight end up being parallel. Well, what kind of angles do these end up being then? Well, they end up being congruent, right? Because if lines are parallel, then alternate interior angles are congruent. So as we apply these, you have to picture the situation, draw it out, identify what angle you're going to use, and then use trig to solve it. So let's go ahead and look at some examples of what it would be. Now, here it says describe each angle as it relates to the situation. So what we're trying to determine is, do we have an angle of elevation or an angle of depression? So angle 1, if you look, that is someone looking down from the mountain to the hiker. And if we're looking down, right, this here would be the angle of depression from the peak to the hiker. Now, angle 2, right, you have the hiker's horizontal line of sight here looking up at the peak of the mountain. So this would be the angle of elevation from the hiker to the peak, okay? Angle 3, now if you look, the hiker, right, horizontal line of sight, bends to create this angle here. Since the hiker is looking down, that is the angle of depression from the hiker to the cabin. All right. Now, what is angle 4 then? Well, here you have your horizontal line of sight here. And as you can see, you're going up. And that is the angle of elevation from the cabin to the hiker. Okay, so that hopefully will help you understand, the difference between angle of elevation and depression. So let's look at a couple of examples here. A meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location. To the nearest meter, how high above the ground is the balloon? So right away, what you have to understand here is you're starting here, okay? And picture this being your horizontal line of sight. And it says, a meteorologist measures the angle of elevation of a weather balloon at 41 degrees. So if the balloon is up here, right, you're looking up at this balloon and it creates a 41-degree angle. Now, they are telling you that from this location, right, the radio signal says the distance from this position to the balloon is 1,503 meters. And they're looking to see how high above the ground. So if I drop a line straight down here, there's my right angle. Okay, well, the height above ground is going to be the measure of this side of the right triangle. So can we use trig to go ahead and find the value of x? Well, from the 41-degree angle, side opposite, this is the hypotenuse, and when we set up our trig ratio, the sine of 41 degrees is equal to the opposite side x over the hypotenuse 1,503, and we basically multiply both sides by 1,503, and x is equal to 1,503 times the sine of 41 degrees, and that tells you that it is approximately 986 meters off the ground. Okay, so it is critical that we are drawing a diagram, picturing the situation, identifying the sides of the right triangle properly, and go from there. Next one, Miguel looks out from the crown of the Statue of Liberty approximately 250 feet above the ground. So right now, we know we're going to draw, and do not knock my drawing skills, the Statue of Liberty. Ooh, this is brutal. Now, as Miguel is at the top, he's looking out, right? But then what happens is he sights a ship over here coming into the harbor and measures the angle of depression at 18 degrees. So Miguel's looking down at this ship, and this horizontal line of sight and that line of sight, our angle of depression is 18 degrees, right? Find the distance from the base of the statue to the ship, all right, to the nearest foot. Well, what you guys have to understand is Miguel's up here. He is 250 feet off the ground. Now, here is the right triangle we are using to find the distance from the ship to the base of the statue. Now, remember, the angle of depression is not right inside this right triangle right now. But what we do have to remember from up here is if you look, right, this angle and this angle, the angle of elevation and depression will be the same or congruent because of the parallel horizontal line of sights. So these are the alternate interior angles that are congruent. So that's going to be 18 degrees. So now, can we use trig to find this distance? Well, this is the side opposite, this is the side adjacent, and that's going to give you the tangent of 18 degrees is equal to opposite 250 over adjacent x. And remember, when x is in a denominator, you are basically flip-flopping positions, and you would get 250 over the tangent of 18 degrees. If you go ahead and figure that out, you are approximately 769 feet from the base of the statue. Okay. All right, the next problem. an airplane flying 3,500 feet above the ground. So right away, if I draw my airplane, this is a little easier to draw than the Statue of Liberty. Okay. So right now, this airplane is, that's not good, is 3,500 feet above the ground, right? Now, what it says here, remember, the airplane right now is flying horizontally, right? But then it says it begins to make a 2-degree descent to the airport, right? So what happens is as it descends here, right? And obviously this is not 2 degrees, but the airport is going to be down there, right? But when we talk about the descent, that's basically saying angle of depression. So this would be 2 degrees, right? And I know that's hard to understand. Everybody wants to say this angle is 2 degrees, but it's, remember, the horizontal line of sight and the angle at which you look down is the angle of depression. But remember, the angle of elevation from the airport to the airplane is equal to the angle of depression from the airplane to the airport. So now we have an angle inside the triangle. So here's the question though. How many miles, right, from the airport is the airplane when it starts its descent? Well, think about it. This is going to be the distance from the airplane to the airport. So the distance from the airplane to the airport is this here, and that's what we have to go ahead and find. So we look, this is our 2-degree, right, angle. This is the side opposite. This is the hypotenuse, which will give us sine. So the sine of 2 degrees is equal to 250 divided by x. Since x is in the denominator, we're going to go ahead and take 250, swap places with sine 2. So divided by sine of 2 gives you 100,288 feet. You have to remember, this is in feet, and it's asking us for the miles. How do we convert the feet from miles? Well, 5,280 feet is equal to 1 mile. So the number of miles would be 100,288 divided by 5,280, which gives you approximately 19 miles. Okay, so for tests and quizzes, converting to miles isn't going to be required, but just to give you an idea. All right, last here. It says the world's tallest unsupported flagpole. So we have a flagpole, right? Is 282 feet tall. Now, it says the shortest shadow. So when we talk about the shadow, that's going to be along the ground because the sun's going to be up here shining down. And as that light comes down, it creates this shadow that is 137 feet long. To the nearest angle of elevation. So when we look, the angle of elevation is going to be here. That's what we're looking for. So if I'm looking for that angle of elevation to the sun, right? Remember, that angle is going to be consistent all the way through. I have opposite, I have adjacent, which is tangent. So the tangent of, I don't know how many degrees x, is equal to 282 divided by 137. And remember, when we're finding angles, we use inverse. So the inverse tangent of 282 divided by 137 gives you the angle of elevation would be about 64 degrees. Okay, so right now, all of these examples should be enough to get you started on the homework. All right, try your best on it. Remember, you can check your answers online. And if you have any questions, I'll be here on Monday to answer them. All right, good luck. Enjoy your weekend.